All right, so our last factoring lesson is on factoring difference of squares. That should have an S at the end. Factoring difference of squares. You've heard that term before. Yeah?
Square.
Difference of squares? When did we talk about difference of squares? Shylin?
X plus 2, X minus 2.
Okay, so when we were multiplying, when you had x plus 2 and x minus 2, remember your factors were exactly the same with opposite signs? So now we're going to be in standard form and we have to factor it. Okay? So how do we know? How do I know when to use difference of squares? So that's the question that we're going to answer for this. How do I know when to use difference of squares? Now we've done some factoring. We've done GCF, we've done the X, and we've done the super X, right? Remember that the super X works for everything. So if you don't know the difference on when to use the X versus the super X always works. Now, it will technically work here, but this is one that you should be able to memorize, and it should be a quick factoring problem for you. Okay, so how do we know? The first thing is there are only two terms. So if you see only two terms, that's a good indication that you could use difference of squares. What else do we use when we have two terms? GCF, right? We look for GCF, but we should look for a GCF first.
When there's a perfect square.
Oh yeah, I'm getting there. 1 second. Okay, so the first thing you want to look for is there's only two terms. The second thing, and probably the one that people forget the most often, is there must be a subtraction sign. Whoops, there must be subtraction between the two terms. So you must have a subtraction sign between the two terms. That's going to be important. If it's not subtraction, it is not difference of squares, right? Difference means to subtract. And then the last one. So these two are easy to identify. The last one you have to think a little bit harder, but not much. But both terms must be perfect squares. What's a perfect square? Jordan, what did you say? Okay. What's an example though of like a perfect square, Shylin?
Like
9?
9.
Yeah. What's the square root of 9? 3. What's the square root of 25? 5. That's a perfect square. Okay, when you factor it, it's itself times itself. Is x squared a perfect square?
Yes.
Yeah, because it's x times x. No, x squared. X times x is x squared. Yeah. Is 4x squared a perfect square?
Yes.
Yes, because 4 is a perfect square and x squared is a perfect square. Okay, so perfect squares are ones where if you multiply the same thing, you're going to get your answer. So x times x gives me x squared. 3 times 3 gives me 9. Okay? So here is how we are going to factor difference of squares. We're not going to use the x. We're not going to use the super x. You need to memorize these. Okay, so first thing you should always look for is GCF. Is there a greatest common factor between x squared and 49, negative 49? No. Okay, now does x squared minus 49 meet these qualifications? Are there only two terms? Yes. Is there a subtraction sign between those two terms? Yes. Are each of these perfect squares? Yes? Okay, so your answer. The perfect square of x squared is just x, right? X times x is x squared. X times x is x squared, so we're going to put x in the front of both of those. And what's the square root of 49? 7. 1's plus, 1's minus. We started with this. Remember when we had the same terms with opposite signs and we went to standard form? You multiplied the first terms and you multiplied the last terms? Okay, so now we're just working backwards. So it's basically the square root of x squared, which is x times x, the square root of 7 or 49, which is 7, one term's plus, one term's minus. Cool beans. Okay, cool. So are there only two terms?
Yes.
Is there a subtraction sign between them?
Yes.
Are the both of them perfect squares?
Yes.
Okay, what's the square root of x squared? X, so x goes up front. What's the square root of 149? 144, 12. 1's plus, 1's minus. Okay, I want you to take a look at x squared minus 8. Go through the qualifications and see if you can factor that. Okay, so I have x squared minus 8. Are there only two terms?
Yes.
Is there a subtraction sign between them?
Yes.
Are both terms perfect squares?
No.
Which one's not?
8.
8. The square root of 8 is a decimal. Okay, which means we cannot factor this using difference of squares. And it actually is not factorable. And if that happens, you're literally going to write not factorable.
Can we just put in
Nope, not factorable. It is extra.
How do you spell it?
Factorable. Okay, so 8 is not a perfect square, so we cannot factor that. Good, I'm glad you caught that. Let's try this one. Whoops. Whoops, whoops, whoops. So I have 49x squared minus 4y squared. Okay, so we're going to do it together. First of all, is there a GCF? Because there's a whole lot extra in this one, so it's something we should probably look for.
No.
No. Okay. Are there only two terms? Is there a subtraction sign between those two terms? Are each terms perfect squares? Yeah? Okay, so let's see. What is the square root of 49x squared? 7x. The square root of 49 is 7. The square root of x squared is x, so 7x. What is the square root of 4y squared? 2y. Good. One's plus, one's minus. Don't make it harder than it needs to be. Okay, you try this one. I'm hearing quite a few answers. So I would like to get answers before I go through this one. So Shylon, what's your answer?
9y squared, and then in parentheses, 9y squared minus y.
Minus y?
Yeah.
Okay, did someone get something different? Carlos?
I got in parentheses 3y minus 3y, and then parentheses again 3y plus 3y.
Someone get something different than that?
That's
9y squared times in parentheses 9y squared.
Like that?
So it would be 6y.
Someone get something different?
Hold on. So put in another answer too.
Okay.
Just-
Hold on. Jeffrey, do you have something different?
9y squared
Okay.
times 9y squared plus y and 9y squared
Sorry, 9y squared what?
plus y
Plus y?
and 9y squared minus y.
And then now I'd like to add one more. Just
Okay.
6y.
What?
6y, nothing else. Because if you do the 3 minus 3, it would cancel each other out, and then 3 plus 3 is 6y.
Okay. I'm going to, so we'll just include on this one 6y because that's simplified form. Okay. The correct answer is not up there. Okay, Ben. Hold on. In parentheses? Okay, so 9y squared.
Plus 3y.
Uh-huh.
That's what I put first by what's called. I simplified it.
answer, right?
That is not the answer. Okay, hold on. Hold on.
That's the answer.
Eliana, what do you have?
Wait, hold on.
Oh,
It's gonna be non-factor.
yeah, it's not factorable.
Jordan.
I lost
Because
it.
the 4
Okay, shh. 9y what?
The 4 exponent.
Mackenzie?
9y squared parentheses 3y plus 1y and then 3y minus 1y.
Not right, but so close. Eliana.
Just 9y squared.
Oh, no.
No? I don't know.
Samantha, I saw your hand.
Is there numbers in the answer?
Never mind.
It is just 1 to 7.
Exactly what the one above it says, but like, take out the ones.
Take out the ones?
Without
That's
the
what you
square.
gave, that's what, oh, it's kind of what we have. Okay, well, all of that's wrong. So, here we go. Some of you are on the right track. What do we look for always first? GCF. Okay? Is there a GCF between 81 and negative 9? 9. I can pull. What does it look like?
Wait, you got it? I put a 4 on my paper.
Well, it definitely looks like a 9.
Never mind. I'm dumb. I looked at the wrong one. Never mind.
Okay.
I'm smart.
So I can pull out a 9. Can I pull out any Y's?
Same. That is.
I can pull out 2 of them. I can pull out a 9y squared. That is the GCF.
But you can simplify that.
I'm not done, dude. Calm down. Okay. If I pull out a 9y squared, 81 divided by 9 is 9. I had 4 y's. I pulled out 2, so I'm left with 2. I pulled out all of this. What's left?
Nothing.
A 1. You can't just get rid of it, because if you got rid of it, that's what your answer is, and 9y squared times 9y squared is 81y squared. But what happens to this term? Where if I distribute that in, 9y squared minus 1 is a minus 9y squared. Okay, so are you okay with GCF? You okay with... We're not done.
Oh, okay.
Okay, now I have to look at this. Are there 2 terms?
Yes.
Is there a subtraction sign?
Yes.
Are both perfect squares?
Yes. Oh, 1 is not.
What's the square root of 1?
1.
1, so it's absolutely a perfect square. Sure it does.
That's it.
9y squared, okay,
1 and 1.
on the outside. What is the square root of 9y squared?
3y.
3y. What's the square root of 1? What's the square root of 1? 1. If you don't believe me, plug it into your calculator. 1's plus, 1's minus.
So I just grabbed the 9y too. So
That's not what you told me.
Second answer. I said exactly what the girl said before me, but
You said take out the 1, not the y.
the Y. I meant Y.
Okay, well, you said
I
1.
also meant the answer too, so.
Okay, so GCF first, and then look at what's in parentheses. We're going to do some more of these. Here we go.
Extra credit to where we get to it.
Um,
I'm always asking.
I don't know either. Let me just give you a few. Okay, let's try those. So number 1, first of all, always start with GCF. There is a greatest common factor, so I can pull out a 2x, leaving me with 2x plus 1. That's all I can do. There's no subtraction sign. Those aren't perfect squares. It's just GCF. Okay. Number 7, I can also pull out a 2, leaving me with x squared minus 8. Okay. There's 2 terms. There's a subtraction sign. X squared is a perfect square. 8 is not a perfect square. How many of you wrote not factorable? You're wrong. You factored out a 2.
Wait, is that x minus 4 and x plus 4?
No, that's your answer.
I am correct.
Okay, so it is just 2 times x squared minus 8. If you factor out, this is important. If you factor out a GCF, you factored. If you can't do anything, no GCF, no x, no super x, no difference of squares, then it's not factorable. Okay, but if you take out a GCF, you factored.
Wait, is
So
6 not factorable?
no, you factored.
But you said it must be a subtraction sign. That's a plus.
Difference of squares must have a subtraction sign. You factored out a GCF. Okay, so one more time. In order to write not factorable, you can't do anything to the problem. You can't do GCF. You can't do x. You can't do super x. And you can't do difference of squares. You literally don't touch it. These 2 problems, I factored out a GCF. So it's not factorable. Like, you can't write that if you factored something out. Okay, those are your answers. Just the GCF. That's okay. That's allowed to happen. Number 8, I can factor out of 3. So x squared minus 9. This now has 2 terms, a subtraction sign, and both are perfect squares. So your final answer is 3 on the outside, x plus 3, x minus 3. Questions? Do not make this harder than it needs to be.